Alright, in this video we're going to familiarize ourselves with the trigonometric ratios of tangent, sine, and cosine, and we're just going to explore the fact that the sine function is the opposite leg over the hypotenuse, cosine is adjacent leg over the hypotenuse, and tangent is the opposite leg over the adjacent leg. And we're going to play around with some numbers and think about what that really means. Use the given trigonometric ratio to determine whether angle 1 or angle 2 is angle A in each exercise. Okay, so when they say angle 1 and angle 2, they're talking about this little picture over here. Okay, so real quick, let's remember how a right triangle works. Every right triangle has a hypotenuse that's across from the 90-degree angle. So this would be the hypotenuse. Now the other two sides of the right triangle are called legs. So this would be a leg and this would be a leg. Now if you pick an angle, then we could describe these legs as being the opposite leg and the adjacent leg. So for example, if I say look at this angle right here, and I'm going to call it theta, then from the perspective of this angle, this leg over here is now the opposite leg. Okay, opposite means across from, and this leg right here, we could call it the adjacent leg. Adjacent means right next to. Okay. Now, if I look at a different angle, okay, if I look at the angle that's up here, now from the perspective of this angle, it's backwards. Now, suddenly, if I'm looking at this angle, then this leg down here is the opposite leg. And then this leg right here is now the adjacent leg. Alright? So opposite means across from or away from, and adjacent means next to or really close to. And of course, no matter which angle we looked at, the hypotenuse was still the hypotenuse. Okay? So now with that in mind, we learned about these trigonometric ratios. The sine of an angle was defined as the opposite leg divided by the hypotenuse. The cosine was defined as the adjacent leg over the hypotenuse, and the tangent of an angle is defined as the opposite leg over the adjacent leg. So with that in mind, let me zoom in. When I look at problem number 1, as soon as I see the sine function, I'm thinking, okay, the sine function is the opposite leg divided by the hypotenuse. Okay, so that means from the perspective of angle A, 4 has got to be the opposite leg, and 5 has to be the hypotenuse. Alright, of course, I mean the hypotenuse is the hypotenuse, so really focus on this part right here. 4 has to be the opposite leg, alright, the leg that's away from angle A. Okay, so looking at this little picture right here, if 4 is the opposite leg, alright, obviously 5 is the hypotenuse, but if 4 is the opposite leg, then that means we must be talking about angle 2, alright, because 4 is opposite of angle 2. So that means we must be talking about angle 2. Okay, so we just put angle 2. Alright, so the angle A that they're talking about must be angle 2. Alright, that's what we're doing. So looking at problem number 2, cosine is the adjacent leg over the hypotenuse. So just focus on that 4 has to be adjacent. Okay, so if 4 is adjacent, then we must be talking about angle 1, because 4 is adjacent to angle 1. Adjacent means right next to. So for this problem, angle 1 must be the angle that we're talking about. So angle 1. For number 3, tangent is defined as the opposite leg over the adjacent leg. Okay, so 3 has to be opposite and 4 has to be adjacent. Okay, so let's see. 3 has to be opposite. I really can just focus on that. If 3 is opposite, 3 is across from the angle, then we must be talking about angle 1, because 3 is across from angle 1. Alright, so we must be talking about angle 1. Alright, and sure enough, 4 is adjacent. So opposite, adjacent, that's angle 1. Alright, looking at number 4. Alright, let me clean some of this up. Alright, looking at number 4, we're talking about the sine function again. So again, sine is defined by it's the opposite leg over the hypotenuse. Alright, so 3 has to be the opposite leg. So if 3 is going to be opposite, meaning away from, we must be talking about angle 1. Alright, 3 is opposite or across from angle 1. Okay, so this must be angle 1. Looking at number 5, cosine. Well, cosine is adjacent over hypotenuse, adjacent leg over the hypotenuse. So if 3 is the adjacent leg, okay, then we must be talking about angle 2, because 3 is adjacent to angle 2, meaning 3 is right next to angle 2. Alright, so when we talk about angle A, we must be talking about angle 2. And number 6, if we talk about the tangent, the definition of tangent, let me clean this up for a second. Definition of tangent is the opposite leg over the adjacent leg. So this has got to be the opposite leg, and this is the adjacent leg. So 4 has got to be the opposite leg. Okay, so if 4 is the opposite leg, then we must be talking about angle 2. Alright, because 4 is opposite angle 2. It's across from angle 2. Alright, so this must be angle 2. Okay, so that's it for this first little section up here. Alright, I'm going to go ahead and end this video here. This is a little short, but we're about to switch gears for the rest of this paper and go into solving these right triangles. But notice, for example, in number 7, none of the angles, well, other than the 90 degrees, we're not given either of the acute angles. And that is, in fact, where inverse trig functions come in. We can use them to find the missing angles. Alright, so that's what the next video will be all about.